Okay, so in this class, we'll be dealing with AWS Lambda, okay, which is a serverless manager. So far, whatever we have done, like working on EC2 server, so we manually go into that option AWS EC2. We looked into the configuration of what kind of a machine we want and what its configurations are. Okay, but there comes a problem. Suppose in future, if you want to change something, okay, something like the hard disk or the RAM or the operating system itself, right? If your
Mm-hmm.
application demands something else, so you will again go and create. The better option would be to go again and create some other stuff, other EC2 server, right? So that's the
Yeah.
first issue people faces. Okay, based on the application, you have to create your server according to that. Or in future, if the server get heavy, or sorry, the application get heavy, you have to change the configuration of your server. That's the first thing. Second thing is that even though if there is less traffic in your application, okay, still all your server which you build manually has to be up and running, right? So that is what it is costing your whole server time, which in terms cost your amount, huge amount of money. Because even though the traffic is less, still your servers are up and running to keep your application running continuously. So to avoid such situations, serverless comes into the picture where the servers are only available when there is a requirement or when there is a traffic hit to your application. Okay. So it's like you don't have the very first issue that we have to go and provision our servers, physical servers. Here you don't have to do anything of that one. Okay. Then pay for the value means the amount of traffic hitting your applications. You will pay only for that one. Okay. You don't have to keep your server kept and running. Again, scale with the usage. As you since you are not provisioning your physical server, so who is provisioning? It is getting provisioned based on the application you are using. So if my application in future gets heavier, that AWS server automatically choose the heavier server for your application. So again, you don't have to select anything. So scale with the usage and the availability and fault tolerance built in. So this is the facility that is already you will find availability, all time availability, as long as your application getting hit. Okay. Any confusion, you don't have to check your server again and again because you are not managing your server. So that's why the
Yeah.
serverless, the name is given as serverless because you are not managing it. But it doesn't mean that there is no server behind it. There is actually a server, but you are not doing anything. Since you're not managing it, so for you, it's a serverless. So these are the basic means greater agility, less overhead. Okay, better focus means you only have to focus on your application, not the infrastructure. Increase scale and more flexibility based on your application. It will adapt the servers. Okay, so again, you don't have to worry about the server infrastructure and faster time to market since there is no time it gets created, but there is actually a little time when a huge amount of traffic comes into the picture. You will see a lacking in the time, but it's a for small applications, it's very quick. Okay, so this is how it works actually. You have to create a function which is known as lambda function. Okay, that's why serverless in AWS known as AWS Lambda. So basically, you create a function. This function is actually your application, nothing else. Okay, and in your application, you have to put some events on it, which will what? Which will trigger your application. Okay, you need to put some trigger as well. So this event trigger the application, which runs the function, and the moment it runs, it gets and pick the services. I mean, whatever the services belong to, either the physical or the cloud. But this server part, you will be not handling. AWS function will handle. Okay, you just have to create an event in such a way that the moment it hit by someone, AWS Lambda comes into the picture. Okay, that's how it's work. So you require some kind of event or a trigger for it. Understood?
Okay. Yeah.
So these triggers or the event source could be changes in the data state, in the sense of if there is some change in the data state, or request to the endpoint. If someone is wanting something from your services, so request, if someone is giving API call, again this event get trigger and your function will run. A change in the resource state. So if your resource state is down, up, or active, it could be anything. Okay, but if there is some change in the state, suddenly this function will get trigger and it will start working or start functioning. These functions in this Lambda function you can write in multiple programming languages. Okay, Node.js, Python, Java, Go, Ruby, runtime API, anything you can choose. So this is how the serverless application in total looks like. Any confusion so far? Any confusion?
No, Adarsh.
So let's go. There are a couple of more things, but we'll come back later.
May know where do we use this Lambda functions in real
In
projects?
AWS? Oh, in real projects, I'll show you. Okay, generally for this one, for whole full-fledged applications or the websites, you do not use Lambda functions. Okay, these functions are basically used. Okay, let's cover those slides as well. When to use it? Okay, so whenever there is some event or some trigger thing that you want, that if this part get hit, it should run something. For example, there is this website known as I love PDF. Okay, PDF. So this website is running. Okay, but it comes into the picture whenever there is, if I want, suppose I want JPG to PDF. Until and unless I'll upload my JPG format, further things won't work. Right. So it's what
Yeah.
this is an event for this website. So until and unless you will not upload it, this event will not trigger the further events. So for such
Correct.
thing, so this one is uh, doc doc processing, you can say. In the same way, you have image processing models as well. So let's say you have to upload an image to your app. Okay, you can use to set up Lambda to automatically resizes, compress it. Okay, we do it right. There's a website known as resize. Okay, image resizer. So again, this one will get trigger when I'll upload some image to it. Okay, its further events get trigger only when you upload something. Otherwise, it won't work. Same goes with I love my PDF. When you want to do some conversion into one doc to another doc format. So when there is a such event-driven websites where you trigger your further function based on the inputs given by the user, at that time you use a Lambda function. Why? Why C? Because for such things, I don't want to keep my website keep and running, even though the website is running, but the further resources which will come after that is not in use right now until unless people put their input into it. So for sorry. So for such resources which are not in use until unless some upload is there, I'm not going to use those resources and those resources are in pause. But if I use physical server, okay, So even the behind task which is required, even required some uploads from the user upload it or do not upload it, that doesn't matter. The afterward task kept running on your physical server. So physical server will be in use and you will be paying for those servers continuously. Whereas in case of Lambda, you don't have to pay uh, unless and until there is some request done by this request done for the endpoint. Okay, that's the first thing. Understood?
Yeah.
Then your data transformation, if you need to clean up or process data before storing in database. Okay, one time task. Suppose this is kind of, you can say, you have to remove it for one time. You just have to clean all the processing data and all before storing anything in database. Lambda comes into the picture. Again, you don't have to put a physical server for this small task, right? Because this is a single time done. And for single time, why would you set up or configure an EC2 physical server, right? So you just write a function for it. So the moment someone come and click that function, at that moment, it will go delete everything from the database and come back. For just minor of second or you can say couple of minutes, your server is being used to clean up all these things. And that's it. Again, it went back to the pause mode. Whereas if you do the same task on your EC2 server to run your function for this cleanup of database, you have to create a physical server. You have to, then people will come. You don't know when people will come and destroy it, but you have to be ready. So your server must be kept and running. Again, you will be charging heavily for that for the process which are not in use. Understood the second point?
Yeah.
And the very important one is the real-time notification. Okay. So there is a one part in contact us page, right? In every website, you will find a contact us page. So that page, if I keep my website in the microservices, so for that purpose only, you can keep a single separate server for it, physical server for it. Okay, where you will keep only the function related to that. Now, nobody is going to use every time that one until and unless there is some requirement to contact you, right? So for such scenario, why would you keep a physical server and you'll pay for that one if it is not that much in use? So for such purpose, if it is one time use or people comes and barely use it, then I'll be using this Lambda one because whenever traffic will come, they will trigger it. It's a trigger based. Trigger based. They will come and trigger it. Then only this notification will pushed and you will be charged only for that small period of time. We'll see the pricing as well. Okay, so that's how it works. Understood. So nowhere you will find that for a website I'm requiring AWS Lambda. Generally, we don't do for a website. We do it for the small event-driven function, which only required people's input. That's it. Right. For the form filling also you can use AWS Lambda. Right. Okay, let's continue. Any question?
No, no.
That's great. Here we have this Lambda. So initially you have to create a function of it. Okay, let's create a function. So you can see how it works. It will tell you .NET, Java, Python, lot of things is there. You write your function over here and run it. Okay. So it will run and the output you can see over here, hello from Lambda. Though it does not look like this, it's just showing how it works. Okay. The same thing you can see in Python also. So you can see the function which is written over here. Here is an event and a context. Okay, so event is some parameter that you have to provide because this function will run when some event took place. Okay, so here they are returning this event as hello, return this one. Okay, and this one is getting returned into this event, and the print function is running that way. So nobody is know where this function is getting called. It is very pretty simple function. Let's create a actual function. So there are multiple ways. First is from the author from scratch. From the scratch, you can create it or use the blueprint. If you already have a function built in, you can blueprint that one, or the container image, basically from the Docker. If you have any application of Docker, okay, you can put the Docker image over here and it will extract it from there. Okay. For now, let's go it from the scratch. Uh, Cloud application. Yeah. There are multiple applications you can programming languages, .NET, Java, Python, okay, Amazon Linux. Even if you want something of your custom, you can use this Amazon Linux too. Okay. OS only
Mm-hmm.
runtime for Go, Rust, C++, or custom. So for the custom, people may see and get uh, fumbled that is it going to support only these many programming languages? What if I have something different and other than this? So you can use for such scenario, you can use Amazon Linux too. Okay, it's provide you the custom option as well. For now, let's go with our Python. Okay, there's the permission section because what happens with AWS Lambda, you can trigger other services as well. So that's why it gives you some basic permissions by default. Or if you have any IAM or IAM existing or any existing role, you can existing this one permissions. You can attach this one with that one. Additional configuration, network setting, VPC. If you have any particular VPC and you want to connect with that one only, you can do that. Okay, that if you want your function to be run on a particular VPC, you can connect with your own VPC. Okay, now let's create it. So this is how it looks like. Okay, diagram, templates in the form of JSON. No, what is this? Can you tell me which scripting
Which,
language is this?
I don't know.
It's YAML.
Oh, yeah, yeah. I was thinking YAML, but I was not aware of this one. Like the remaining one. By seeing that resources and all, I felt, but again
Just see
that.
the indentation. Okay? See the indentation, and you can see the architecture. They have given a list kind of this. If it is a dash,
Mm-hmm.
it's a list. Okay, under this one, and that's it. Indentation and this kind of a list or data dictionary. You can see dictionary, not data dictionary. Sorry. Okay, so it's a YAML one in template format.
Yeah, yeah.
Okay, so here is your application, and this application code is written over here. Okay, and this UI, can you see something uh, similar to any other UI? This one?
VS Code.
Yeah, right. It's exactly equal to VS Code. So whatever
VS
you can
Code.
do in VS Code, you can do over here. Okay. Whenever you do any changes in your application,
Mm-hmm.
suppose CloudWatch right over here, you have to first deploy your your changes, and then you have to test it. So for testing it, you have to create a test. Okay. So This is okay. What is this? Which scripting language is this?
Scripting language. Asking.
Or you can say just like a YAML. What is this? It's a JSON format.
Still. Okay.
Okay, JSON format are also in the form of key value. Okay,
Mm-hmm.
the thing is, it comes in the curly braces, and YAML you won't find in the curly braces. So here indentation doesn't matter. If
Okay.
I can put it back and front, doesn't matter.
Okay.
So if you have some for testing any application, you give some parameters and you are expecting some values. So if your code
Mm-hmm.
matches with that one, then only your code is passed. Otherwise, it get fails. Right. For now, we are just removing it. We just keep this format empty. Okay. You have to name your test cloud test and save it. If it's done, if I'll go in this test code, let's test it now. So you can see status code 200 and body is showing this CloudWatch. CloudWatch is basically the one that we put in the body. Okay. I can even write print. This is first task. Save it. Okay. Yeah, this is already saved, so no need to save it. Deploy it and test it. So one thing, if you'll see here, you do not see the output like you usually see. Okay, like here I have written this is my first task, but here you will see it will show only the response which is present in this written one. Okay, so for such things you can go to the monitor. Okay, there are a lot of ways to monitor your. You can use view CloudWatch logs. So you need to have the idea of CloudWatch. All the logs you will see over here. Okay, see there is one log got created. If I click on this log, so I can see my whole logs over here. Okay, when it get started, when the request get ended. So if you see the timing as well, it's 25. This is the timing of this European timing, Stockholm. Okay, based on that. So all the logs of your application, you will come and see over here. Okay.
Mm-hmm.
And 3 days, 1 week, all the past log as well. 3 hours back. So see, we did something right now. So that's why it is showing here some event. Okay, just now we did little bit. We can, you can even add some triggers to run your function. What does it mean that if I add some triggers, if I go here and do S3, lot of triggers are here. Okay, bucket name. Do I have any bucket? My unique Terraform S3 bucket. Do I have? Let me just check. Okay, there is one bucket is there, and this bucket was created in this region. Is there anything inside? Okay, there is nothing inside so far now. So I'll go here. I'll run this. So remember one thing, bucket region and the lambda function should be on the same. Okay. So
Okay.
I'll create another bucket for that one. Create a new bucket. Permissions block. Versioning if you want to add. We covered all these things, right? Remember that? Bucket versioning,
Yeah, yeah,
YAML.
yeah.
Great. And yeah, it's created. Bucket name should be unique. This one is already taken. What else we can add? Underscore. Hmm, This one is this. No uppercase. Okay. Now let's go here. Just refresh. Lot of triggers. Alexa, basically the Amazon Alexa, you know it, right? So even through
Yes.
voice also you can trigger your application. Then API gateway, if any you want someone hit your API and suddenly your services start running, you can do that one. Application load balancer as well you can do. Okay, these many services. SNS basically the messaging and all. You can synchronize with that one as well. Apache Kafka, very demanding nowadays. So let's go with our known one, S3. Oh, what is this? Bucket region is US East 1. Lambda function is EU North 1. How come this? God. So remember, once you created your bucket, you cannot change the region.
Okay.
So to keep eye on your region. Mm, provided. Event type, there are basically a lot of event types. Put, post, copy. Means anything is being put means if anything is pushed in your bucket, it will trigger. Post means if anything get posted on your bucket, it will trigger. Of anything copied in your bucket get triggered. Okay, or multiple uploads completed on your bucket, it will trigger. So like this. So for now, let's choose all the bucket, all objects, create event. It means whatever anything happen in your object, in your bucket, it will trigger your function. Okay, and that's it. Suffix, prefix, we don't have to add. I acknowledge it. Edit. So now if anything happened to this, any event took place in this one. Okay, so for now, let's go to our CloudWatch, and if you see, I'll just refresh it. Just keep eye on the timing. So Python runtime, AWS Lambda, okay, EU North one, this one, right? European North one. Okay. Let's do something on our Lambda. Not this one. Release this. Let's upload something over here. Add files. Do we have anything? Okay, let's upload this one. This get uploaded. Then we'll come here. We'll go to the monitor. So the time this has got increased, okay, for a couple of seconds it run. But let's go with the precise one. See, another event got triggered, right? Earlier we were having one. The moment it runs second time, another event got triggered. This is difficult. This is my first task. This was our output, right? Which I
Yeah.
wanted to show you over here. But when we run our code on this one,
Here we have.
yeah, when I
Yes.
paste it over here, it won't show you here. See, it won't show you here. All the response thing it will show you. Status code is 200, body is 200. But the proper output of logs, it won't show you here. So for that purpose, you have to go to the monitor and the CloudWatch to see that one. So if this event didn't run, like for now, if you see, we have two log streams, right? One we run on just 7 to 8 minutes back, right? Means it's 6 p.m., 4 p.m. And after few minutes, 6:15 p.m. again we run the second one. If I upload again, I upload something over here. Let's upload something more. So, this one got uploaded. I'll go to the CloudWatch and I'll refresh this one. If it is not showing you from there, see, you will see a small green dot over here. This is the recent one. And click on the CloudWatch from here. It should have been updated directly over there. Only two is showing. Show one more. New object, we uploaded it. Latest. Let's go here. Okay, so what it is doing on the same log, it is putting 3 times. Means the very first time we run manually, second time we trigger through our first object we pushed into this one, and the third we pushed uploaded just now. So just for the confirmation, okay, all the 3 cases printing the same output. What I'll do, I'll just put some another message for the confirmation that it is updating it. I'll just instead of first, this is cloud task. I'm writing cloud watch task. I'll deploy it. Okay. Now, if I go right now to our monitor, so far I have not tested it, so it won't do anything. Okay, you will find the only 3 that we have pushed so far, that we run so far. Now I'll upload something over here. Upload this one. Now if I upload this one, it got uploaded. Yeah, I'll come here. Put monitor. CloudWatch. Okay, so until unless there is some time difference, if you do some changes on the same time, it won't show you the another log. But if there is time difference, then only you see the log. So right now it's 6:21. We'll go here. We'll check. This is the CloudWatch task. Understood? The trigger based event.
Yeah.
Any question? Okay. So we were having difficulties that why it is showing still 2. It might be because of the time lag. It might be having some 1 or 5 minute time lag that changes were done in after 5 minutes, then only it shows. But all the changes you will see. If it is done on the same time before that one, it will show you on the previous log itself. So everything would be there. Okay. There is another part is there, layers. Okay, layers basically means if I go here and I add any library which is not available. Okay, what do we do generally in Python if libraries are not available? Any idea? Suppose if I want a this one panda. Okay, so
Mm,
there is a
mm,
library known as panda, or for
mm.
APIs request library. Okay, suppose if I do request library. Okay, and if I use some part of this request library into my this function, so what would
Mhm.
happen? It won't run your application. Why? Why? Can you tell me?
Because it doesn't have that library.
Yep. So if I take one JSON sample API did India well. So this JSON sample library, basically the JSON placeholder, it will provide you a simple API keys. Okay. So if I run this one, you will see the output like this. So if I just copy this URL and I'll go to my CloudWatch application, config.py, let's give it a name URL and paste it over there. And I can do import URL from config. Okay. And import request, you can give some values also just for the testing purpose. So AWS request dot get URL means it will fetch that URL and whatever the output you want to print in the JSON format. So I'll just remove this one. In this status code, I can write RAW, AWS dot status code, and then after body JSON AWS text. I can do like this. That's it. So what it will do, it will fetch this URL from the config file, okay, and then it will use this URL into this API format as a API format and put the value over here, and we will want to show that one in the form of JSON. Okay. Or I can, instead of this one, I can simply write rws.json. Okay. JSON. Now, where do I get this library? So for that task, what I will do, you can simply create a file over here. Suppose Python. I'll go inside. Just the author. No need to create anything. Just go to the terminal. Create, install, request, and -t. From where do we want? We want this to be installed on this location. So everything is getting installed over here. Now what you have to do, when we create this one, if you go to this layer, here it will ask you to add a layer. But before adding a layer, you have to create a layer. Then only you can choose custom. You will go to this custom layer and you will have to choose from here. So I'll go here, click on layers, create layers. Okay. Upload a zip file, give it a layer name, suppose packages, py packages. Okay. Let's give it a name, cloud packages. Cloud packages, choose a zip file, but we do not have created the zip file yet. So either you can do it through the UI based, or you can simply use a zip command to zip it. Okay. Then I'll choose it. Okay. Any description if you want to write. Now this one, you need to choose compatible resource, compatible architecture, x84-86, and then the runtime. Okay. So mostly people, what I initially did is few errors. I chose all these things Python version. So what happens? This layer will run on all these versions. Okay. But you miss one thing, that your application was built on Python 13.3.13. So it should be available for you. And then create it. Can you hear the shouting? A lot of people
What? I'm not
shouting.
getting.
No, in my background, a lot of people are shouting.
Okay.
I hope it is not bothering.
No, no, it's not audible that one.
Okay, that's good. Okay, we got this one. Now we'll go back to our Lambda function again. We'll add a layer over here, add a layer. And you can choose the layer is available, cloud package. Version 1. So you got the layer added to it. Now if I try to run this our application and deploy it and test it. Okay, it's giving some kind of error. Let's check what is the error. So even if you see the response in the form of this one, JSON format, right? The one that we wanted. But we wanted something else. Let's see what is the issue. Status runtime, user code syntax errors, some syntax errors. Syntax. Request. is wrong. Or come import URL. Oh, again the status is failed. What is the other error? Comma. Forget a comma. Where is the comma? Okay, we forget the comma here. Now it got succeeded. And you can see the response. You got this response, right? And this response you got because of that URL. Okay. If this URL won't be present, basically the API URL, you won't getting be this. You won't be getting this user ID, title. What was the title over here? This title, right? It is in some languages. I don't know what language it is, but you can see the same output you are getting over here by hitting that URL. So how is it got possible? Through this request library. And how did we get this?
Mhm.
We added this library through our by installing it on
Mm.
our local and then zipping it
Mm.
and putting it as a layer. We also see the event driven. Now again, if you run it, I can see the logs over here in the CloudWatch again. You can see there is some movements happening. Hmm. So lot of times it time. The recent one is the top one. Did we remove that print function? Yeah, we didn't remove. So since we did not remove, that's why it is showing here as well, right? So that's all about AWS Lambda. Okay. You can make more complex to this one. Okay. You can add further more libraries in a different file and you can then put it as a layer. You can put lot of triggers over here, not only one. You can add multiple triggers. Destiny, where do you want to deploy your application? You can choose this one as well. Okay. So it's basically you have to attach Destiny as a if it is a notification based. So what it will do, it will send a notification as well. Or if you want to put your whatever the thing you will get from output you will get from this Lambda, you can put on your S3 bucket as well. Okay. Or you can put in the another Lambda function too. So a lot of things you can do. Okay. So Destiny type you can choose. Any question from this serverless?
No, actually, but I need to look once again. This is like very new
Yeah,
topic to me.
correct, correct. But understanding wise, anything that you think
No,
which is still not clear.
actually, can you explain, in a high level, why did we do this? Not like a detailed, but whatever you explain,
Mhm.
can you once more say we did this because of this?
Yeah, so the thing is, it is generally in case of this event-driven function. If I'm having something which I want this function to be run, for example, the trigger base is the image. Okay, in general case, if you say the image based a trigger, that the moment the user input its image, I want to take that
Okay.
image. You can integrate with that image, whatever the user put, and you can do some
Mhm.
modification on that image. For example, resize. If my Lambda function is like, it's a resize function if I write over here. Okay, Python resize function for our image. So what this Lambda function required? The image location. The image will come from through your this S3 bucket. You put something on S3 bucket, it will trigger this one. Okay, my function will take the image from this one, resize the image. Okay, and once it resizes, I'll put the destiny to the S3 or wherever I want. So for this task, I need not to create any server. Okay, nothing configuration, nothing required. Only the event-driven functions will get triggered on the spot. The this server got created and it is in the pause state because now this function is not running because no one is uploading any image. Until unless any images get upload, our function will remain in the pause state. So I don't have to pay a single penny for my functions which is not in use. Whereas if I use it in a EC2 machine, so I have to keep this function kept and running because you don't know when your customer will come and hit your application. Got it? So for this
Yeah.
scenario, this is one of the scenario of high level. Okay,
Mhm.
where
Okay.
someone even for the booking ticket also, you can do this task. Right. Someone chose a booking ticket, multiple options, and you put a trigger on that one. Okay, you can create an API as well. So there are a lot of things there. Or you can in CloudWatch also itself you can do that if any server in CloudWatch, if the alarm is red or if anything got triggered in this CloudWatch through other services, you can trigger this function. Okay. If any application or any contact or any messaging or any push thing comes in your SNS, you can create that one. Apache and Kafka is currently very demanding. So this required another topic. So in this way, anything that you want get triggered, okay, while without bothering about creating server for that specific use, then
Mhm.
this picture, this lambda function would come into the picture.
Yeah.
Okay, so if somebody asks, you can basically gives the image one, resize one.
Okay.
They'll understand. Okay, that we were having some functions. Okay, so whenever the user upload any image on our S3 bucket, we take that image, and the moment we establish a trigger with that one as well. So the moment that trigger happens, a function runs, and at that very moment, the user get the image resized. Okay, and for that we did not to have configured any EC2 server, or we need not to bother about the configuration. Neither we need to pay a lot of hefty tasks because our server is not continuously running until and unless the traffic comes into the picture and they trigger our resource. But if it is not in use, we are not going to pay for that. We are not paying through this serverless one. So you can see AWS Lambda pricing. Mm, Getting start for free. Price code. Mm, let's see. Oh, here it is. So you can see uh, for $0.02, $0.2 per 1 million request. Okay, what does it mean? It means the 1 million times your lambda function get hit 1 million times, then only you will be charged $0.2 for that one. Okay,
Mhm.
for every GB second. GB basically the size, uh, it's a kind of a size one. Okay. So
Okay.
this much amount, which is again a very less amount for the
Mm.
for the amount of request that you are doing. And the same thing if you compare with the EC2 machine, okay, but you don't know when will your 1 million requests or how many requests comes into the picture, but you have to keep your server running all the time. So again, so for such purpose, AWS Lambda is a great deal, right? And you can correlate with your own. I'll just stop it for now. Okay.